Alright, so part 2, functional performance brake system component with the subsystem, the function of the performance character with the selected brake system component with the subsystem, presently you with the presented with the selection of following order: brake air hose with the coupling, angle cocks, brake pipe, fittings, brake control valve, air reservoir, brake cylinder release valve, brake retaining valve, brake rigging, hand braking, slide adjuster, brake shoe, each of the above the brake system with the subsystem that discuss the terms you've developed their performance of problems associated with their use. Figure 2, 1% of the following page as aided with the illustrated location component with the typical car to indicate the function and interaction with the component with the respective freight car brake system. Alright, show the retainer and ABD valve, brake pipe, auxiliary reservoir, release rod, combined auxiliary main emergency reservoir, slack adjuster, cylinder, brake cylinder, cylinder lever, top rod, truck lever connection, brake beam, brake shoe, bell, crank, truck lever, handbrake, angle cock, hose, and coupling. Arrangement of the brake system component with the typical freight car for the Air Brake Association 1972. You have the permission of the copyright owner. 2. 1. Brake air hose and coupling. Air hose and coupling. Glad hands provide flexible pipe connection between the cars and the train. And shown with the following page. Figure 2.2. The air hose is part of the subassembly. Link loose hose coupling with a 2 clamp with the pipe nipple attached with the brake pipe with the car. Alright, show the nipple with the note with the marking with the top of the nipple must be lined up with the coupling and with the identification and label with the shown. And note that the coupling of the figure, coupling figure 2 with the Association of American Railroads 1978B with the page E51 1978. Use permission of copyright owner with the air hose coupling with the glide hose incorporated with the rubber gasket from the seal with the connected with the manually raising 2 air hose ends with the give with the proper angle with the lowering of them in such a manner that allow the coupling to rotate relative to each other, either causing flanges of the coupling to engage. Air hosing up and coupling is performed automatically when the 2 cars are being pulled apart during the mechanical uncoupling process. Tension force produced and the air hoses of the car separate, cause the coupling to move vertically, upward rotate so that their flanges become disengaged, permitting them to separate. There are presently 2 AAR specifications for the air hose, namely specification M60171, AAR standard specification M60153, AAR alternative standard. Other types of air hoses have been tested recently with a primary emphasis with improving the air hose life, with the use of include with the air hose with the brave steel with wire reinforcement, use with the material with neoprene. Primary disadvantage of using alternative materials has been extremely hose rigidity and current encountered during cold weather operation would make it difficult and if not impossible for one man to manually bend the hose to their coupling position. According to the AR Interchange Rule 5 of the wear limit is gauging with the care with the renewal of the air hoses follows the Association of American Railroad 1975 of the Rule 5. Burst leak discernible without soap, but it does test abrasion, cracks, soft points, etc. Loose and defective fittings either end of the hose, end of the hose 5 3/8 of an inch or more shoulder on the either nipple with the coupling pores so that it determine the soap stud test. Splice over 8 years to determine with the date of the hose date will obliterate with the time of the COTS and ITDNS and air brake missing. To ensure proper function with the air hose with the glad hands so with the assembly with the properly mounted with the line with the cover with the proper air hose with the mounting with the alignment become difficult to ensure under all operating conditions, especially with long freight cars having long overhanging couplers are supported by shafting absorb with the cushioning the device with the long travel distance. Although specification air hose assembly installation requirements are specified by the AR 1975B with the air hose step problems of the one most frequently cited deficiency present air brake system and the railroad data survey performed by the current project 12 out of 17 railroads include air hose coupling ended with the car with arrangement and one of the airs that should be given to the highest priority improving the freight train with the brake system. Angle cock is shown in figure 2.1. The angle cock is normally attached to the end of the brake pipe at the end of the car with the purpose of the angle cock to provide manual process for the airflow with the cutoff of the brake pipe. Angle cock is typically used with a portion of the train to be moved separately during the picking up the setting out of the blocking of the cars from the road train. For example, if the block of cars to be set without over the head end of the train would manually close the angle cock on the rear of the last car over the head end of the block to be set out. Upon uncoupling the train at this point, the air hose would separate with the towing the rear unintended portion of the train into emergency to prevent it from moving. This would occur with the moment we cover the angle cock of the front end over the front car would be left into open position. The front portion of the train could then be moved with the air brakes charged and properly functioning. Angle cock location specification provided AR specification number 5218 with the section E manual standard with the recommended practices. Figure 2-3 show the specification angle cock air hose the location with the location overhanging greater than 5.5 feet from the truck center end of the car. Alright, show for the hose shown in the E32B 1976. Show for the floating sill, with the fixed sill, with the coupler, with a minimum maximum of the glad hand note 2, with the standard with the 22-inch length hose. AR approved flexible hose stationary bracket floating with the swivel type hanger, train line, and floating sill. Alright, Association of American Railroads, 1978B with the PE 32A, 1976G with the permission of the copyright owner. Suitable angle cock, location of difficulty specified along cars over the certain coupler cushioning device with an addition with the air hose separation problem that discussed previously. Both the angle cock and the air hose can be damaged by bypass coupler impact during switching classification operation. 2-3 brake pipe. The fitting of the brake pipe, like with the one shown in the figure 2-1, is constructed with a 1 1/4 inch extra heavy pipe with a 1 1/4 inch diameter has been selected with the optimum diameter to satisfy both the airflow and volume requirements of the brake into a long train, as shown in figure 2-4 with the typical freight, and concludes the other type of addition with a 1 1/4 inch brake pipe, selected with the minimum bending radii with all the brake system components. Piping specified with the Air Manual Standards recommendation procedures. Figure 2-4 shows the piping arrangement typical freight car. Shows your DBD or emergency air auxiliary emergency portion services, a branch sheet, an auxiliary emergency reservoir, and the alright, they're a little bit too small to read, but this one would be your over here is your A1 quick service relay valve, the glad hand coupling branch pipe T, a retaining valve, brake cylinder, and then over here would be the glad hand 2 as well. Alright, pipe installation procurement and specification are published from the AR specification number 258-2518, with one of the primary functional performance aspect of the brake pipe with the air brake system leakage presented between the connecting fitting of the various brake pipes. Topic of the air brake system leakage addressed in the permanent paper of the Palmer 1975 of the paper dealt with the various air brake system leakage improvements made over the past 50 years. The plan following two sort of the leakage of the A brake pipe, leakage of the brake pipe, the hose with the assembly angle cock with the brake pipe with the charging ports, or the AB type control valve. System leakage with the valve with the least for the position of the fully charged with all leakage list for the brake pipe with leakage of the reservoir with the control valve leakage. Although the leakage test performed over the past 30 years with the controllable test met with the criteria for the resolve of the show with the total brake system leakage decreased over the period of time. Table 2, when compared to the leakage test, the result of the test made over the past 50 years. Comparison of the brake system leakage test with the results over the period of the test 50 years based on 1925, 1950, 1975, 1925. Total leaks in total cars, 1925, 1950, 1975% of the cars tested that had leaks, and those were the hose, gasket, angle, cocks, brake pipe, branch pipe, brake valve, reservoir, base number, and percent. Note the based on audible leaks in source Palmer 1975, table 1. Result of the table 2 will be based on the difference over the procedure for the criteria illustrated with the air brake system leak of the decreased over the period. With the example of 1925, 87.4% of the checked cars charge checked had brake pipe leak. In 1950, only 9.8% of the cars checked for the had brake pipe leakage. Furthermore, in 1975, only 1.1% of the cars checked had audible brake pipe leakage. More recent, with the test result of the exam of the Palmer dealt with the effect of the cold weather has on brake system leakage. Although the test was involved with a small pipe, a small sample of the observation of the following result of the indicated cold weather adversely affects the leakage. Temperature for the less effective of the brake pipe leakage for the system. Temperature of the system leak. The average at car evaluated consumes 0.42 cubic feet of free air each minute. All pool railroad repair facilities indicate that 40% of all of the cars tested have too much leakage to pass to the single car test originally tested. Tends to say that in the past 25 of the leakage level that have not changed appreciably, but the proceeding for the test was performed sample air brake system leakage varies for the number of the typical cars and acceptable operating condition. The results of these tests can be interpreted with considering the historical development of pipe fitting for the present requirement of the prior to 1950 brake system will likely commonly result of the fracture of the added air with the brake pipe fitting. For the earlier 1950s fittings were introduced the belonging rubber compression grip. However, the leak of the problems persisted cold weather due to the insufficient tightening of the glad nuts for the compressing fittings. This led to the introduction of welded fittings presenting AR rules of the required replacement compressing fittings of the welded fittings when a car is shopped for 150 or more man hours for the work. Compressive fittings and welded fittings are illustrated in figure 2.5. Alright, compressive fittings, compressive ring, nut, and pipe lock ring. Body and flange ring, and then it shows the welding fitting with the figure 2.5 of the brake pipe fittings. Also related to the function performed with the brake pipe fittings, LEs with which the fittings can be repaired with the problem of the baleen Hangel with the Hangel 1971 with respect to the problems associated with the repairing leak for the cars with the gushing underframes installation brake pipe with the gushing underframe with the cars between the sliding with the stationary center sills has made locating the repairing leak of the damaged pipe very difficult without disseminating of the underframe with the more designation and attention for the need within this area. The author continued, except for the brake leakage is one of the major contributors to poor train handling. This take rectifier can be due to the leak of the pipe with the cover with the improperly authorized train line with the fittings which allow the pipe to shift during the coupling of the slag action. The effect of the air hosing of the gasket of the inner angle cock. Sometimes this type of defect is easily defected. Detect that during the terminal drift, during the train movements over the stretching out of the train, leakage or more occur with the train line with a more adequately anchored copper car compression fittings would seem to be more vulnerable. This could become the real problem when the brake pipe is attached with sliding sill. Cushion Carter unfortunately, in many of the instances, has led to practice with the torsion cutting and access holes of the stationary at center sill in order to tighten hiding fittings. In addition, affecting overall train brake performance, leakage of the direct impact with the rate train operation because of the rules governing the operation of the rate trains require that the air brake leak be less than 5 psi per minute of the brake pipe gradient with less than 15 psi with the uncommon practice the limited train with the length of the cold weather operation in order to meet the legal minimum leak requirements of the shown figure 2.6 of the following page for the minimum brake gradient of 15 psi with the difficulty to achieve the 100 car train operative with the ambient temperature of below with 0 degrees Fahrenheit. Show the temperature of the gradient in psi of 0 to 107 degrees Fahrenheit and approximate with the brake pipe gradient with the versus temperature of the typical 100-car train. Palmer said 1975 with curve 1, U for the permission for the copyright owner. Comparison showing brake pipe leakage versus the ambient temperature shown in figure 2.7 of the following page. Show the brake pipe leakage psi in a minute with a 0 to negative 10 to 60 degrees Fahrenheit, and then as shown in 2.7, the maximum leakage requirement over the 5 psi per minute may become difficult to achieve with a 100-car train with an ambient temperature drop below the freezing point. While both curves are shown in figure 2.6 and 2.7, approximation for the 10 to illustrate the leakage limit of the more restricted brake pipe gradient. The result has been partially reasonable with the request for the validity of the 5 psi brake psi per minute leak rate limitation be re-examined. U for the gradient instead of the brake pipe leakage is only the criterion ensuring operable train brakes discussed in the Piper, Plain and Hangel of the 1971. This paper of the practice limited the satisfactory brake control of the trains assessed as the airflow demand under 60 cubic feet a minute, preferably 50 cubic feet a minute or less, by establishing a relationship between the brake pipe gradient with the leakage the authors conducted. To keep the airflow rate to 50-60 cubic feet per minute, less of the gradient must be held with 5 psi for 50 cars, 110 psi for 100 cars, 15 psi for 150 cars. Effective all leakage of the brake pipe this would correspond with the brake pipe leakage 20 psi minute for the minute for 50 cars, 30 psi minute for 100 cars, 8 psi minute for 150 cars. However, the 8 to 10 psi minimum brake pipe leakage or stopping distance becomes adversely affected. The effects of the brake system leakage of the training brake per train performance discussed in part C of this section. Brake valves. The function performance specification of the brake valves are contained with the AR manual standard recommended in practice with the specification pertaining to the operational response of the brake valve with respect to the relationship with the other valve components of the air brake system of the freight train. Function performance character for the brake valve is used today described in terms of the AB and ABD brake valve addition. More advanced brake valves are present under the evaluation, including the ABDW and the Z1A primary function and performance aspect of each of these valves is discussed in the following paragraphs. 241, the AB control valve. The AB valve is the most common control valve used in today. Such for the function performed the AB valve is considered the same with against the brake valves compared. AB valve, which was introduced in 1930, we replaced the K valve. The last K valve was removed with the interchange surface of 1953, shown in figure 2A with the primary performance feature of the AB valve with included better quick surface functioning, retarded recharge releasing, ensuring the more sensitive application of the Ordnance K. Additionally, the AB and separated emergency portion aligned with a made much faster emergency transmission over 900 feet per second to control the slack action. During the brake application, the AB valve was provided with the initial fast limited to brake cylinder pressure with bolt bunch slack, followed by a more gradual pressure build-up, giving the full pressure in approximately 12 seconds. Emergency portion pipe bracket, serve the portion releasing a reservoir releasing portion, brake cylinder release valve portion, figure 2A AB brake control valve with the QRB brake cylinder release valve, the exterior view of the Air Brake Association 1972, permission for the copyright owner, with the AB valve with a full emergency application for the 150 car train required approximately 17 seconds to wear its full surface. The application required 2 to 3 minutes of the development. Develop the maintenance of the requirements of the COT&S for the AB valve are presently based for the period of 48 months. Hard 242 for the ABD control valve by the 1950 for the operator with the long freight train with the need for the greater flexibility of the train braking operation become apparent with the desirable direct relief of the feature of the brake with the difficult to achieve within long trains, especially the leakage was concentrated in the rear with the less for the brake pipe pressure could be increased with a high rate with the head end of the train leakage with the rear end of the head. Rear end could cancel the release signal with increase the brake pipe pressure for the end, then brake with the rear of the train would not relieve to prevent the train from being pulled apart during the release of the moderate or a heavy brake application for the trains would be allowed to stop completely before releasing the brakes, recognizing the need of the direct relief of the capability while trains are in the motion brake control for the designers developed. The accelerator for the relief feature of the brake control of the valve, the features allow with a small amount of the air with the emergency compartment with the air reservoir to enter the brake pipe with locally with the overcome Leakage effect with the accelerator with the release propagates with the train at a speed of 450 to 600 feet per second. Accelerated release feature was first demonstrated with the AC valve, later incorporated with the ABDE valve shown in figure 2.9 below. Shift the emergency portion, the pipe bracket, the surface portion, and the release portion of the combined release rod. AB control valve, the exterior view of the Air Brake Association, used the permission of copyright owner. It should be noted that the facility conversion of the AB valve with the ABDE valve with the surface emergency portion over the ABDE valve can be mounted with the original brake pipe bracket used for the AB valve. See figure 2.8 and 2.9. By changing the design material of the ABDE valve, the COTs and the COTs and AS materials period of the ABD valve recently extended by 8 to 10 years, compared to 4 years for the AB valve with Association American Railroad's 1975C. 243, the ABDW brake valve with the ABD valve with the design that provided running release capability to produce the faster, more effective brake pipe pressure, but increase the air was also a need to increase the time applied with the brakes of the train in order to reduce the stop distance. To assist the making of the brake applicator for the long cars having the large brake pipe air valve, the device known as the A1 reduction relay valve was designed to apply with the A1 reduction relay valve, which is illustrated in figure 210, assists the AB and ABD valve with making the brake application of both service and emergency rates. Show the quick service valve portion and the pipe bracket of the vent valve portion, figure 210. Show the A1 reduction relay valve, serve the Air Brake Association, use the permission copyright owner for the pipe reduction of the service rate with the quick service valve portion, A1 reduction relay valve, local vents, brake pipe, air for the choke with the service rate through assisting with the propagating of the service application through the train for the brake pipe, reduction the emergency rate with the vent valve portion of the A1 reduction valve, locally vents the brake pipe air to the emergency rate. The requirement of the mandatory illustration of the A1 reduction relay valve on all cars have more than 75 feet with the brake pipe in attempt to prevent deterioration of the brake performance caused by the increase of the percentage of the long cars. However, the feature of the desirable for all cars, regardless of the length of the response to the need of the ABDW. The brake valve was designed to integrate with the continuous quick service, so the feature upgraded service braking on all cars at the lower cost with the improved functional performance over the A1 reduction relay valve with the ABDW valve is shown in figure 211 in the schematic with the internal passage of the ABDW valve is presented in section 3, figure 3. Figure 211 shows the ABDW control valve with the emergency portion. Figure 212 shows the manufacturer performance comparison with the ABDW control valve full service brake application. Show the improvement in the brake cylinder build up time in seconds. By the car number, improvement in performance, improvement the car number, the full service reduction. Source writer 1975, figure 5, used with the permission of the copyright owner. Shown figure 212 with a 150 car train, complete with the equipment of either the ABD brake valve. When the manufacturer predicted about almost 50% of the improvement of the brake cylinder pressure build-up time, that should be noted that the ABDW control valve has been demonstrated with the brake equipment. The committee over the AR isn't presently under consideration for acceptance. Interchange service members of the road. 244, the Z1A brake control valve, the Z1A brake control valve, another advanced brake control valve presently under consideration for the AAR approval of the interchange service according to the manufacturer of the Z1A valve as designed with the provide reduce the initial cost of the maintenance cost to provide improving the performance, reducing service operation, service propagation time of the valve leakage if it was designed to be fully compatible interchange with the ABD types brake valves presently in use, and outline view of the Z1A brake control valve is shown in figure 213. Figure 213 shows the Z1A brake control valve. According to the manufacturer, Z1A would have the longer potential for the life, longer, lower maintenance cost than present brake valve because of the use of the poppet valves instead of the spool type valve, with the attributed with the two main casual factors of the restricted life of the spool valves. Rubber seals 1. Rubber seals were rapidly application of the spoon valve involved with the movement of the seal over the ports with the spore. 2. The high velocity of the air moving around the spool to remove the lubrication, which is critical for the long seal of life. And the function performance during the full service of the application relief of the Z1A shown in figure 214. Show the PSI in the event of the 0100 PSI's brake pipe front, brake pipe rear. Z1A control valve 75 to 100 foot cars full service of the application release. The event with the brake cylinder front with the brake cylinder rear. Figure 214 functional performance Z1A brake control valve during full service of the application and release. Westinghouse brake signal 1975. 25 air reservoir. The purpose of the air reservoir is stored with compressed air with the braking energy during the brake relief when it is needed with the emitted with the brake cylinder with the brake control with the bearing of the brake application. Air reservoir shown figure 215 with the two separate compartments. The auxiliary compartment is stored with the air for the service of the brake applicator for the emergency compartment. Restored with the emergency brake application. Show the air reserve figure 215 track train dynamics 1973 with the permission of the copyright owner. The volume of the auxiliary air reservoir compartment system system charged 70 psi would produce a brake cylinder pressure approximately 50 psi following the full surface application of the emergency component of the air reservoir with a volume of 3,500 cubic inches. Strength of the equipment initially charged with the 70 psi of the both reservoir volume of the brake with the cylinder pressure will equalize approximately 60 psi following the emergency application with a standard 10-inch cylinder with a 8-inch piston travel to WAP code 19677, page 9. Table 2 show the full surface emergency brake cylinder equalization pressure requirement, the different valve of the value of the initial brake pipe charge pressure. Full surface emergency equalizing brake cylinder pressure versus initial charge brake pipe pressure, initial charge brake pipe pressure with the equalizing brake cylinder pressure and full surface PSI emergency. 70 and 50 and 60, 75, 53, 53 and a half, 64, 80, 57 and 69, 85, initial brake full surface at 60.5, emergency 72, 90, 60, 90 brake pipes initial charge, 64 full service emergency P77, 171 full service 85 emergency PSI, 110, 78 full service PSI, 90 emergency 93. Alright, as shown on table 2, the emergency equalization brake for the cylinder pressure approximately 20% of the grain with the full surface of the cylinder brake pressure regardless of the full value of the full and initial brake pipe pressure. The result of the pressure value of the volume relationship between this emergency auxiliary air reserve compartments and the brake cylinder. 2.6 the brake cylinder. The purpose of the brake cylinder with the piston with the provide with the braking fork with the car with applying with the brake shoe against the wheel during with the brake application with the brake cylinder exists in two types. One type of conventional indirect acting with the brake rigging AB1 or ABU, and a different type of the directing acting truck mounted brake rigging. Figure 216 illustrates the AB1 type of the brake cylinder with the conventional brake rigging. So figure 216, a typical brake cylinder used for the conventional brake rigging. Air into the brake cylinder through the port of the left is displayed with the position piston. Correct for the return springs applying with the force of the brake rigging. Total brake cylinder volume must be properly retained with the air reserve volume to produce the required brake cylinder pressure to produce the proper force and developed by brake cylinder depending on either the higher friction, lower friction brake shoe. The the brake cylinder proper diameter must be slick with the design brake system. In addition, with the brake system, freight car can be verted using low friction, high friction brake shoe and installing the bushing kit of the brake cylinder to produce the effective piston diameter, thereby producing a low braking force. The brake cylinder with the bushing kit installed in shown figure 217. 217 brake cylinder bushing kit. Alright, 2.7 the brake cylinder release valve. The purpose of the brake cylinder release valve is to prevent the manual bleeding of the air of the brake cylinder over the car with the brake pressure for the deplete with the preparation of the switch for the classification U with the brake cylinder. The brake release valve eliminates the need to bleed the air from air reservoir compartments, therefore reduce the time and the need of the recharge reservoir during the outbound train preparation. One of the manufacturer of the brake cylinder release valve that estimates 40% of the time can be saved with each charging a 150 car train, and each car has the valve installed. Brake cylinder release the valve mounted with the direct with the pipe brake with the AB valve of the recent manufacturer that can be installed with the older brake AB brakes valves by use of an adapter kit with the ABD brake valve incorporates the brake cylinder release valve with the standard feature of the shown figure 218. Alright, 218 show the pipe bracket surface portion brake cylinder release valve with the emergency portion. Brake cylinder release valve is an integral part of the ABD brake valve. Track time 1973 used the permission copyright owner. The performance and specification brake cylinder release valve that provide with the Association of American Railroads 1875 PP E35 and through E42 with the manual actuation valve with the single with the magnetary with the pole with the release valve with the deplete with the brake cylinder pressure. Although this feature is desirable, the car inspected within several years with the routinely bleed both of the brake cylinders and the air reservoir by holding the release valve to prevent the air and reserve from leaking from the defective brake cylinder release valve. Reapplying with the brakes, the problem was also described in the railroad survey result of the Part B, Section 4, Table 4.3 through 4.11. 2.8 retaining valve. The purpose of the retaining valve is to maintain a minimum amount of the pressure brake cylinder after the brake release has been made with the car reservoir being recharged. The feature with the U with the surface setting with the grade territory so that the train brakes are not inadvertently released. Retaining valves on each of the car may be manually set with the bolt activation and release. Bolt prior to 1967 and with the retaining valve incorporated 4 position setting as following: EX direct release, no air restriction. EXHP retains 20 psi brake cylinder but train brakes are replaced. EXLP retains 10 psi with the brake cylinder, train brakes are released. And the EXSD slow direct exhaust brake cylinder pressure is completely exhausted but at a slow rate. 1967, the 3-position retaining valve was introduced. Figure 219 with the 3-position retaining valve omits the XE LP position. Both include the XE, HP, and S position. Functional Performance Association. Both types of the retaining valves presented with the Association of American Railroads, 1975. Show the 4-position, 3-way position of the Air Brake Association with the permission of copyright owner, 1972. Prior introduction of the dynamic brakes over the release of the diesel electric locomotive, the retaining valves were used routinely for operating heavy trades on steep descending grades. Today, however, the retaining valves are usually only under certain circumstances, particularly on severe grades when dynamic brakes are not available or from a coal mine tipples to the yards of main lines or certain exponential steep over 2% mainline descending grades. Section 4, Table 4.2. Alright, 2.9 brake rigging. The purpose of the brake rigging is multiply the distributed braking force, develop the brake cylinder, to the brake shoe, with the cover, the introduction of many different types of length, for the capacity of the brake cover, the demands have been placed for the problem with the design of the air brake, with the design rigging. Both producers adequate braking level that can be physically attached to the brake car without interfering with the other devices, applications, braking. Brake rigging is used today include the two types of indirect acting conventional braking, direct acting truck mounting braking. With the functional performance of both types of the braking must be such that the Association of American Net Braking Ratio with Specification C Section 4 adhere to 291 conventional braking indirect action figure 220 that illustrates the four typical configuration conventional type of the brake rigging. Any of the several different brake rigging arrangements can be used depending on the configuration of the car and the other factors. Achieve the required brake ratio. Design for the conventional brake rigging can cover the force produced with the brake cylinder multiplied with the selecting the proper lever ratio. The lever ratio must be limited to no greater than 12.5 to 1, but a double acting automatic slack adjuster achieve the system for the pressure of the volume relationship between the air reservoir and the brake cylinder is not adversely affected with the brake shoe wear. Also, stressfully produced on the lever rods, jaws, and pins must be limited to the inherent design value. The area AR specification will cover the metal badge plate fastened to the underframe of each of the brake cars, showing the design, brake level, the dimension of the brake rigging. Example: the brake rating plate. Badge plate is shown figure 221. Because of the net braking ratio included the loss of efficiency varying brake the braking condition components. Section 3 estimated the efficiency error neither the design show the efficiency law of the compensate for the brake rigging force design calculation efficiency law of the various brake says components of this made with the test result of these tests indicate efficiency various configuration for the brake rigging differ considerably. However, the approximate efficiency value have been determined and shown in the table 2.3 on page 32. Show the bottom rod through the bolster, and then we're going to zoom into this. Show that the rod, the bottom rod under, top rod under, and hook and eye, 3-lever truck arrangement. These are 4 configuration conventional brake rigging. A little bit small to read. We're going to go back to 50%. Alright, show the brake pads plate showing the dimensions of the freight cars. Minimum height, minimum height, minimum height, minimum height, and materials, and then Association of American Railroads 1978 PE 7196 with the figure 47 the U for the permission copyright owner. Table 2.3 approximate value of the efficiency loss of the brake rigging components. Type of the component approximate efficiency loss. Brake cylinder 7.5, 11%. Brake cylinder 8-inch 10. Brake cylinder 8.5 9. Brake cylinder 10-inch 8% efficiency loss. Brake cylinder 12 7-inch 7 efficiency loss. Pins 1 per pin. Slack adjuster 5. Horizontal pads 1. Unit beams 1 per beam. Field testing also produced with approximately efficient for the range of the brake rigging. The various type of the brake car with these result the shown with the conventional brake rigging efficiency can be ranged with the minimum approximation, approximately 45% maximum, approximately 75%. May inherit a disadvantage certain arrangement of the conventional type of the brake rigging, the turning of the turning moment, and due to the reaction force of the brake rigging during the brake application according to the manufacturer of the truck mount with a typical brake rigging, the turning force can produce lateral force exerted with the flange wheel against the rail. The magnitude of the force can be ordered by 490 pounds. Depending on the pound of the brake rigging configuration, figure 222 illustrates these forces of the two configuration conventional rigging. The asterisk says the test show has been systemically truck forces caused truck of the parallelogram McLean 1973. Top rod over bolster, dead lever anchored to the truck bolster, lateral force, top of rod forces, frictional movement and turning moment, lateral force. Bottom rod under bolster, dead lever anchored to the car body. Top of the rod force, lever anchored car body. Truck turning moment, lateral force produced with the configuration conventional brake rigging. Our interview with the deck with the freight car wheel manufactured by the car line leasing company with the affirmative that the large portion of the wheel of the roof with the form worn flanges of the wear with the pronounced with the two wheels of the truck, one each of the axle. This is asymmetrical wheel wear is said to be called describing the truck turning moment to produce with the conventional brake rigging. A second problem in the area with the conventional type of the brake with the rigging with the uneven brake shoe for the distribution produced the errors various wheels of the cars by producing a higher than average brake shoe force on one wheel of the car compared to the others at the end of the cause the wheel to slide if the car isn't empty with the shrivel. The thermal loadings can result with the wheels if the car is loaded. Conventional rigging can also be bottom out if the rigging is not manually adjusted with multiple wear wheels. They have to replace with by one wear wheels depending upon the type of the rigging with the additional brake shoe for the travel required with one wear wheels can be called with the rigging to come in contact with the truck bolster with the center seal making the brakes useless. 292 with the truck mounted rigging direct acting the truck mount with the type of the brake rigging combined with the function with the brake cylinder brake rigging of the brake beam with the compact truck mounted arrangement. Figure 213 illustrated with the truck mounted brake rigging was designed with the WAPCO. The rigging has been traded with the name of the WAPCO PAC. Similar rigging produced by the New York Air Brake Company has been traded with the name OCO PAC. Show the illustration typical truck mounted brake rigging on the one truck shown. Air Brake Association 1972, you have the permission of the copyrighted owner. As shown in figure 223, the truck mounted brake rigging requires 2 brake cylinders per truck with 4 cylinders per car. Brake cylinders are directly open upon the brake beam is efficiently lofted and here with the conventional type of the rigging with the not present with the truck mounted rigging of efficiency with the typically range between 80 and 90% off their business associated with the truck mounted type of the brake will include the absence of the truck turning movements result with the brake application shown in figure 224 with the truck mounted brake rig will produce the symmetrical application of the brake force. 224 shows the force distribution truck mounted direct acting brake rigging. The more uniform force distribution produced with the truck mounted brake rigging surface produced with the tendency of the wheel to sliding empty cover the high wheel thermal loadings only on the one over the car. Principal brake system design problem with the truck mounted brake rigging is though, even though it's more efficient with the conventional rigging, the effective lever ratio is only 2 to 1 compared with the lever ratio of the 12 to 5-1 for conventional brake rigging. In order for the net brake ratio that required with a high capacity of the car with the use of the truck mounted rigging, the high friction brake shoe that are required with the use of the conjunction large diameter of the brake cylinders, operating disadvantages associated with the truck mounted with the brake rigging have included the most common the COT and S expensive to become with the maintenance of the car with the 3 additional brake cylinder damage of the brake cylinder with a coal hopper that causes the exposure to flame the thawing shell with the cylinders also frequently damage of the car derailed. More serious, the problem which recently the correct with the manufacturer has been handbrake the range of the truck mounted rigging until the recently with the handbrake of the rigging and applied with the brakes only one end of the B end of the car with the provide adequate holding capacity capability of one truck. The handbrake brake force had to be substantially greater than that produced with the truck car equipped with the conventional rigging. Furthermore, inspection of the car whereas ground crews would often result in the incorrect interpretation of the release brake that the AM of the car meant with the hand with the brake of the car had been released, resulting in the relatively high frequency on release handbrakes combined with the insubstantial higher handbrake force produced by a higher incident of the B end of the wheel removed due to the slide, spelling of the belt with up to tread with the correct has been provided with a handbrake rigging that applied with both trucks and the car. WAPCO 1975. 210 handbrake. The main purpose of the handbrake is to hold the car in stationary for a long period of time, although the handbrakes are also used with a limited number of the operation controlled manually with the speed of the cars during switches. Classification due to the car's impact force. The handbrake of the freight cars can be generally described in terms of their means of physical application. This includes the vertical wheel assembly, horizontal wheel, usually drop of the shaft of the assembly or lever type of assembly. Figure 215 shows the illustrate typical vertical wheel load wheel hand brake assembly. Or the handbrake is manually operated with the crew member with the operating the wheel, which when it was chained with around the sprocket with the sprocket with the gear to the wheel with the chained with by a ratchet or the reduction gear with the resulting force with the transferred to the brake. Some of the brake rigging through the combination sheath wheel with the bells crank depending upon the design with the car with the brake rigging. Handbrake must be released manually. The activation release rather by unwinding the wheel depending upon the design. Unfortunately, releasing the handbrake isn't sometimes overlooked with the cars moving and training with it. In the air, the handbrake applied with depending upon whether the car is loaded with the wheels must be slid over the skip of the cars and flash above the high tread temperatures respectively. Performance of the specification for the handbrakes are published in the Association of American Railroads 1975 with the use of specification vary according with the type of the brake rigging of the brake shoes installed on each for the car. 211 slackage of the purpose of the slackage of the nerve of the smooth with the slack with the conventional brake rigging to do with the brake shoe for the other way with the show of the brake cylinder with the piston trouble to maintain with the proper piston trouble to maintain with the trouble of the pressure for the volume relation between the air reservoir and the brake cylinder is not out of balance. Brake and lever ratios are 8 to 1 show wear with the 1/8 of an inch covered by 1 inch piston travel extension. This reading the FRA and the AR requires less than 9 inch piston travel the initial terminal of the brake shoe condemning limits are specified. It should be noted that while proper piston traveling is important, piston travel is not indication of the total condition of the entire higher brake wriggling position. Typical are provided with the brake wriggling lever to rise with the correct lever angularity interference or interference by manual relocating pin replacement with the square up of the rigging. Figure 21626 illustrates the operation one type of the automatic slack adjuster. Automatic slack adjuster operation shows the slack adjuster. Alright, Simon's Boardman, 1970, with the permission of the copyright of the owner. The mechanical slack adjuster shown in Figure 226 consists of the enclosed with a long spiral worm rotatively attached with a ring with a unit designed with a short and automatically when the brakes are relieved to adjust the brake shoe wear. When worn, brake shoes are replaced with the new ones. The unit automatically lengthens for the first brake application to provide proper position and travel. The slack adjuster group according with their point application for the brake rigging and their type of the operation of the mechanical pneumatic is shown in Figure 227. The performance specification certification proceed with the automatic slack adjusters are published in Association of American Railroad 1976 publication papers 57 through 63. And it shows the groups typical AR application automatic slack adjusters. Simon Boardman, 1970, used with the permission of copyright owner. Alright, 212, brake shoes. The number of the different type of the brake shoe of the presently with the the freight surface the shoe with the different primarily in their material of the construction which alter the friction wear of the sparking with the character of the standard cast iron brake shoe that often referred to as low friction shoe with the shoe that has been in service rule since 1935 presently being phased out by the introduction of the high phosphorus of the cast metal shoe. 1965 the era adopted the alternative type of the brake shoe known as the composition shoe with the shoe with which also referred to the high friction shoe with the developed partially to be the with the truck mounted rigging which because lower effective lever ratio required a heavier friction shoe with the head achieve the required level of braking and should be noted. However, all the composition shoes are not high friction shoes. Low friction composition shoes are manufactured and are used. The primary locomotives typically have the higher brake force than freight cars. The summary of the brake shoe terminology shown in Figure 2.4. Summary of the brake shoe terminology: material cast iron, high phosphorus, high friction no, low friction yes, composition high friction yes, and low friction yes. 2.4 illustrates terminology problem of braking shoe for the purpose of the section of the following meanings are used. The cast iron low friction metal with a high phosphorus low friction metal composition high friction composition low friction is ignored unless otherwise specified. 212.1 cast iron shoe for the cast iron's brake shoe for the designated with the AR1 was adopted in 19th over the material specification of the cast iron shoe published with the AR specification M40156 figure 228 illustrates the dimension for the pattern numbers of the different cast iron shoe thicknesses. Association of American Railroads 1978 BE 93 1972 with the use of the permission of the copyright owner. The functional performance of the cast iron brake shoe involved with the friction character of the relative of the shield of the freight car, weight of the friction value of the vary with considerable depending on the operation conditions, some of the extent of the brake shoe force of the particular whether directly affected by the speed of the value efficiency of the fraction shown with the table 2.5 can be considered an approximate range of the cast iron brake shoes. Approximate frictional character of the cast iron brake shoe with the function of the train speed. So 0575 10 20 50 miles an hour. The Holloway 1950 and calculated friction coefficient frictions. 212.2 the composition shoe of the composition brake shoe with the developed in the early 1960s to provide higher frictional level required with the truck mounted braking was provided to improve the wheel wear thermal capacity characteristics. Section 5 compared with the cast iron shoe with the specification of the higher friction composition brake shoe are both the AR specification M92672. Figure 229 new next page illustrate the dimensions of the composition shoe with the AR shoe type designations and then show the high friction composition typical brake shoes. Association of American Railroads 1978 BE 94A 1971 youth permission of the copyright owner. Functional performance and feature of the composition of the indicated with addition with the overall high fractional value of the coefficient frictional increase with the railroad train speed compared with the cast iron shoe which have the coefficient friction with the decrease of the train speed with the table 2.6 illustrate with the approximate value of the coefficient of the friction over the composition high friction brake shoe. These values were calculated using the test data. Approximate value of the coefficient of the friction composition high friction brake shoes 0, 5, 10 and then 10, 15, 25, 30 all at 0.30 approximate coefficient fraction. Extent of the dynamometer test have the demonstrated the increase of the wheel theoretical capacity achieved with the use of the composition brake shoe compared with the cast iron brake shoe. Section 5 resolved in the interview the professional, industrial, and general support with the conclusion of the research of the brake shoe with the wear also said to be greatly reduced with the use of the composition brake shoe. 212.3 high phosphorus shoe with an effort to reduce the sparking characteristic of the cast iron shoe. High phosphorus content with the cast metal shoe has been introduced as an alternate to the standard cast iron shoe. Friction character for the high phosphorus shoes are approximately the same as the cast iron shoe with the table 2.7 over the following page illustrates approximate value of the coefficient friction of the high phosphorus shoe. These values were calculated using the breakaway test data. approximate value of the coefficient of friction of high phosphorus tube, 0, 5, 10, and then it goes 10 is 0.25, 15 is 0.17, 20 and 25 is 0.15, and 30 is 0.4 approximation coefficient friction. A graphical comparison of the friction characteristic of the three types of the brake shoe discussed in the preceding and percentage of the figure 230. Other functional performance characteristics are compared in Table 2.8. Table 2, other 8 functional performance character for the H high phosphorus transition brake pads, where compared cast iron improvement reported in the brake shoe wear, high phosphorus improvement reported with the bowl shoe when wear, sparking characteristics compared to cast iron greatly improved the nose, sparking virtually sparkless, wheel thermal capacity compared to cast iron unknown and improved in composition. Brake shoe that are replaced with the field, remove with the spring with the type of the brake with the brake shoe, hold the brake shoe with the brake head over the brake beam after the new brake shoe has been positioned, the key with the vertically reinserted through the slot provided in the brake head with the back of the brake shoe. In figure 228, with the two types of the brake shoes, key shoes are shown in figure 220 through 30. Two types of brake shoe keys. Alright. Association Manual Errors 1978 BE 94 1972. You have the permission copyright of the owner. Because of the substantial greater friction level of the higher friction composition brake shoe, it is important that the composition shoe is misapplied to the car design with a low friction shoe. Although the presently occur with the present physically the procedure are ineffective to prevent the misapplication of the brake shoe. Furthermore, the rules which become effective in 1977 will make it physically impossible to misapply brake shoes. The procedure in effect with the presently and those will become effective in the future are shown in Table 2.9 of the following page. And show the 2.9 the summary of the rule of the design to prevent misappointing misapplication of the brake shoes. Chapter 3, Operation, Performance, and Design for 8 of the car air brake systems.